Hello everyone, my name is Navin and today I am going to explain you about amplitude modulation. So let's we go into that. So what is amplitude modulation? Amplitude modulation is a process by which the wave signal is transmitted by modulating the amplitude of the signal or the carrier. It is often called AM and is commonly used in transmitting a piece of information through a radio carrier wave. Amplitude modulation is mostly used in the form of electronic communication. In nowadays, we can see amplitude modulation is commonly used in fields such as radio transmission. There are many types of amplitude modulations. Those are double sideband full carrier, double sideband suppressed carrier, single sideband suppressed carrier, and vestigial sideband. So as you can see, here is an example of amplitude modulation. The top one is a message signal. The second one is a carrier signal which will be transmitted. So in order for us to easily transmit the signal into a far regions, we will change the amplitude of the signal. As you can see, the third graph is how the amplitude modulated signal looks alike. So there are also such a thing called quadrature amplitude modulation or QAM. This is a method of combining two amplitude modulation signals into a single channel. This approach helps double its effective bandwidth. QAM is also used with pulse AM, which is also known as PAM, in digital systems like wireless application. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hibatullah bin Muhammad Firdaus from Group 4. From, so, I for my task, I need to present about angle modulation. So, for angle modulation, it is also called as exponential modulation. And it is also used for modulated signal in order to change the phase and frequency of the carrier signal. It also can encode an information for time varying signal and time varying frequency. These are the general equations for the angle modulation. So, from the angle modulation, we have divided into two further for angle modulation, which is phase modulation and frequency modulation. For frequency modulation, the amplitude and the phase of the carrier signal are remain constant, but the frequency are changes. As you see in the graph, in this graph, so this statement, the amplitude and phase are followed with this graph. Then for frequency modulation, the frequency deviation of the carrier are directly proportional to the modulated signal, as you see in this equation. So we know that the frequency deviation of the carrier are directly proportional to the modulated signal. And these are the FM signal equation, frequency modulation signal. So next, these are phase modulation. The amplitude and the frequency of the carrier signal are remain constant when the phase of carrier signal is changes. So as you see in this graph, you will see that the phase of the carrier signal is changes when the amplitude or the frequency are remain constant. So the phase deviation of the carrier are directly proportional to the modulated signal, as you see in this equation. And these are the phase modulated signal equation. Okay, that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamu alaikum and hi. So my name is Nazaruddin and I'll be explaining on the radio digital modulation. So before I start, let me put on a laser pointer. So what is a digital radio digital modulation? So just like our previous example, it is pretty similar, but the only difference is that in this radio digital modulation, we uses a digital signal as its incoming signal, or we can say as its information signal. So in this radio digital modulation, we have three main types of modulation technique, namely amplitude shift keying (ASK), frequency shift keying (FSK), and phase shift keying (BSK). And moving on to the first main technique, amplitude shift keying (ASK). Uh, this is actually a technique in which we represent the digital data as the shifts in the amplitude of the carrier wave. So example, we will represent the smaller amplitude for 0 bit and larger amplitude as 1 bit according to the digital signal that we receive. So this can also be called as on and off keying or interrupted continuous wave, ICW. So this is the basic concept. So as you can see here, we have the information signal coming in digital data 10110, and the carrier signal is in analog. So here we have the output VASK after going through this multiplier. So as you can see in this output, the waveform has been shifted according to the digital data that we receive 10110, and we can see clearly 10110. So this is basically the for the generation of the ASK. We can use a multiplier, or either we can use a on and off switch. And as for the receiver part, we can use envelope detector or also current detector to receive the signal and change it back to its original state. Say, so we move on to the next one, frequency shifting. So this frequency shifting is actually a frequency modulation scheme in which the digital information is transmitted through discrete frequency changes of carrier wave, and we can generate this FSK waveform by adding two ASK waveform together with a summing amplifier, and the two ASK waveform should be of different frequency because we would want to have that difference in frequency. So here, as you can see, is a basic concept. We have one signal of VASK coming in. We denote this as V1. Going through the inverter, it become V2 because it has been inverted. And here it is, both of these signal is combined with a different oscillator frequency. So this is the output wave. So here we have a higher frequency, and here we have a lower frequency, and both of these will be added together using the summing amplifier to generate this wave. So in this VFSK wave, the higher frequency we usually denote it as value 1 in the digital representation, and the low frequency as 0, and this as 1 again. So this is the main idea for the generation of the real FSK signal. So moving on to phase shifting. So phase shifting, this is the modulation technique where the carrier phase shift to one of a finite set of possible phase. So we usually use 90-degree and 180-degree for this one, but it have another extension of this technique which uses 4 phase degrees, but we'll see onto that later. So this is the main concept. So for the main concept, we have uh, the information signal coming in and also the carrier wave signal. And this is the output wave that is generated. And as you can see, it has varying phase. So how do we read the phase? So this is the technique. As you can see, each time the phase changes, it denotes that it should change from its either from 0 to 1 or 1 to 0. It should change its state. So as you can see here, starting from a constant value, it start the phase here. So it means that there is a phase change. So a phase change denote that from 0 it just should change to 1. And here it will stay 1 until another phase change occur. So it should from 1 to 0, and as you can see here, it will stay in this one value, 1 bit value, until a phase change occur, and it will change from 1 to 0. So that is the main idea for this phase shifting. So for the generation, we can use a multiplier and also the receiver. We can also use a multiplier, and here we have a coherent detector. Okay, so this is the extension of the phase shift king. So in the phase shift king, we have another type. We call them as quadrature phase shifting. So in quadrature phase shifting is slightly similar to the previous shifting, but the only difference is that we pass on 2 bit per symbol for this quadrature phase shifting. So what is a symbol? So actually a symbol is our representation of our waveform in how many bits we send. So for our previous example, we would send like 1 bit per symbol or 1 bit per waveform, you can say. But in this QPSK, we would pass on 2 bit per symbol. And since we use 2 bit, so 2 bits will start from 00 until 11. We have 4 different type of variation. So since we have 4 different type of variation of bit, we would use 4 different phase reversals such as 0 degree, 90 degree, 180 degree, and 270 degree instead of using just 2, because 2 we will only have 0 and 1, so would only have 2 variation. So this is the main idea. So we have a carrier channel here, our carrier signal, and this is our modulated result after we combine it with the digital signal. So here we have a 00100111. So this is slightly more efficient than the one before, since we are able to transmit more bits per symbol. So this is the end of the video. Thank you for watching.